Hello, Algebra 1 students, and welcome to your 7-4 video on factoring polynomials. So, we, thus far, have done adding polynomials. We've done subtracting, we've done multiplying, and now we're going to do what is called factoring. So, when we do factoring, factoring is like division. So when I say it's like division, what I mean is we're going to be taking things out, right? Or breaking things down. When you multiply, you distribute in. When we factor, it's like we're undistributing, right? So again, think of it as division, okay? All right, so let's take a look at what we got here. Okay, so our first example here. So it says find the greatest common factor. What is the greatest common factor? GCF of the terms 12x to the fifth plus 8x to the fourth minus 6x to the third. Okay, so when we're looking for a GCF, right, there are a couple things we're looking for, right? Number one, we're looking at the variables, right? Number two, we're looking at the coefficients and the constants, and number three, we're looking at the first sign here, right? So for this problem, notice, right, that all of the terms have x's, all of the terms have numbers. We are bound to have a GCF here. Now, for this first example, what I'm going to do is I'm going to break this down into its simplest of parts, right? So let's take a look at this 12x to the fifth. So 12x to the fifth. Okay. I'm going to break 12 down using its prime factorization. So this is a technique from your elementary school. So the smallest prime is 2. I'm going to divide 12 by 2 to get 6. Okay? And then I'm going to divide 6 by 2. I'm going to divide 6 by 2 to get 3. So these are the prime numbers that make 12. So 2 times 2 times 3. And then this x to the fifth means 5 x's multiplied together. So 1, 2, 3, 4, 5. Okay, next, I'll come over where? Let's go over here, all right? Let's do 8x to the fourth. Okay, let's break the 8 down. So again, we have 2, 8 divided by 2 is 4, 4 divided by 2 is 2. So 8x to the fourth is 2, so we have 2, 2, and 2 are its prime numbers. So 2 times 2 times 2, and then those 4 x's multiplied together. And then the last one is going to be the 6x to the third. So we have 6x to the third, break down 6, divide by 2 is 3, and they're both prime. So 6x to the third is going to be 2 times 3, and then 3 x's multiplied together. So when we look for this GCF, and I'll change colors to blue, when we look for the GCF, we are looking for what numbers, factors, and the number of x's that are common to all three of these terms. So let's look at the numbers first. Notice that each one has a 2. So there's a 2 here, a 2 here, and a 2 here. So we know that our GCF will include a 2. Okay, and that 2 is going to be gone. Now, this 12 has a second 2, 8 has a second 2, but 6 doesn't have a second 2. So you can't put a second 2 in your GCF. And then 3, 12 has a 3, but 8 doesn't have a 3. Even though 6 has a 3, right, 8 doesn't have a 3, no more. So there's no more numbers. Okay. And now we look at the x's, right? We have 5 x's, 4 x's, and 3 x's. So all of them have 1x, 2x, and 3 x's. But that's it, because the 6x to the third is all gone. That means that x to the third is going to be part of your GCF. And this is the GCF, 2x to the third. So now what we do, right, is we are going to write out 2x to the third. And now I'm just going to multiply out what's left over. So 2 times 3 is 6. X times x is x to the second. Okay, plus, okay, 2 times 2 times x. 2 times 2 is 4. X minus, and then from the 6 we just have the 3. And this is what we're going to be doing here today when we factor out a GCF? We're going to pull out the greatest common factors, and then we're going to leave what's left over. Now, when we talk about what's left over, there was two processes. The first process is we divide the coefficients and constants by the 2. So notice that 12 divided by 2 is 6, 8 divided by 2 is 4, negative 6 divided by 2 is negative 3. Then with the exponents, with the x to the third, we subtract 3 from every exponent. X to the fifth minus 3 is x to the second. X to the fourth minus 3 is x to the first. There's a hidden 1 there. And x to the third minus 3 is x to the 0, and it goes away. And this is what we're looking to do, pulling out GCFs. Okay, so let's take a look at another example here. Okay, all right, so it says, why is it helpful? We're not going to worry about that. We're just going to try to factor out the GCF. Okay. All right, so let's identify the GCF. How are we going to do this? Well, the first thing is I'm going to look at the variables. I see a variable here, a variable here, and a variable here. All of the terms have the variable. So this x has an exponent of 3. That means there's 3 x's. This has an exponent of 2. This x has an exponent of 1, right? This dot should not be there. It's just that that's a dot. So when we're looking for the GCF, if all of your terms have a variable, right, you're going to remove the smallest exponent. So for the first thing, all terms have the variable. And again, I want to put x because not always. So if all terms, and I'll put all terms have the variable, you're going to look at the smallest exponent, exp for exponent. So in this case, the smallest exponent is x to the first. That means this x to the first is going to be part of the GCF. I'm going to leave a space, x to the first. Next, right? Negative. If the first term is negative. So you see how this first term has a negative sign? That means your GCF will be negative. Okay? What that's going to do is that's going to end up changing the signs when you take it out. So again, we'll talk about that. Okay? And then the third thing, I'll do it in purple. Right? So if all of your terms have a coefficient or constant other than 1, so all terms have coefficient or constant not equal to 1. So if all of your terms have a coefficient or a constant not equal to 1, you're going to examine the smallest number. So now in this case, we have 12, 18, and 27. 12 is our smallest number. Now I don't care if it's negative 12, it's just 12. So I am going to list out the factor pairs that make 12. So give me two numbers that multiply to get you 12. So we start with 1. All right? So 1 times 12 is 12. Then we go with 2. 2 times 6 is 12. If you don't know, just take 12 and divide it by 2. You get 6. Then we do 3. 12 divided by 3 is 4. Now my next number would be 4, but 4 is already there, so we can stop. These are the factor pairs. So now I am looking for which of these numbers is the biggest that divides into 18 and 27 as well. Okay? All right. So, I mean, you can do whatever you want to, right? So like, does 18, is it divisible by 12? No, it's a decimal. Is 18 divisible by 6? Yes, you get 3. Is 27 divisible by 6? No, you get a decimal, right? Is 18 divisible by 4? No. So I'm just checking all these numbers. So 12 is not going to work, 6 is not going to work, 4 is not going to work. Okay, is 18 divisible by 3? Yes, you get 6. Is 27 divisible by 3? Yes, you get 9. So 3 is going to be in our GCF. So for this problem, negative 3x is our GCF. And now what we'll do is we'll do two things. I'm going to do it in green here. Number one, we're going to divide your coefficients by 3, and it's going to be a -3. Divide by -3. And number two, we're going to take our exponents and subtract 1 from all the exponents. Okay? So that's the two things we're going to do. So I'm going to pull out the GCF, so -3x. I don't need x to the first. -12 divided by -3 is +4. X to the third, take away 1 is x to the second. 18 divided by -3 is -6. Take away 1 from x to the second, you get x to the first, x. -27 divided by -3 is +9. X, take away 1 is x to the 0. It goes away. And this is going to be that factored form. So there you go. So this is your guidelines on how to factor out the GCF. Okay. Notice here it talks about factoring, puts it into smaller coefficients and smaller exponents. So everything is smaller, and that makes it easier to continue to look and analyze later on. Okay. All right, and what is last here? Okay, so again, area is or an application of multiplication with polynomials is area. So here we go. So if the area of a rectangle is given, use factoring to find the dimensions for the missing, find the expressions for the missing dimensions. Okay. So if you think about this, right? So this question mark right here belongs to this first rectangle and this second rectangle because it's also here or here. That side is common to both rectangles. This question mark is going to be the GCF of this polynomial. 9xy squared plus 12x to the second y to the third. The GCF will be common to both. Then when we get what's left over inside, that's going to be these pieces up here. And again, what we'll do is we'll label the picture once we're all done, right? But this is just another GCF problem. Because think about this, right? This is representing the area. Area is base times height. We are looking for the, sorry about that line, we are looking for, let's call this the height, and let's call this the base across the top. That makes this area. And that's exactly what we're doing when we factor. When we factor, we're breaking it into its factors that would multiply to get back what you get. All right. It's undoing multiplication, like division. Okay, so let's talk about the GCF. All right. So I have my GCF here. Okay, so first, the variables. Now notice there's two variables. There's x's and y's. So the first term has an x to the first, the second has an x to the second. So they both have x. So there will be an x in our GCF. You take the smaller exponent, that's going to be x to the first. Okay. Let me write this down lower so I have more space. So GCF equals, skip a space, x to the first. Now they both have y. We take the smaller exponent, that's y to the second. We do not have to take the same variable from the same term. The y to the second could have been here and the y to the third could have been here. We still would take the y to the second. And then we look at the two coefficients, 9 and 12. We look at 9. I'm going to put 9 over here. Its factor pairs are 1 and 9. 2 does not go into 9, but 3 does 3 times. And we're done because we get the second number again, 3 and 3, so we're done. Okay. What is the biggest of these that go into 12, right? We know they go into 9, so which one goes into 12? Well, 12 is not divisible by 9, so 9 doesn't work, but 12 is divisible by 3. You get 4. So that means that 3 is your GCF. And there's our GCF, 3xy to the second. That is going to be the dimension right here, 3xy to the second. That's this height, if you will, of the rectangular picture. So now we're going to take that GCF out, 3yx to the second. We're going to divide by 3. So 9 divided by 3 is 3. We're going to subtract 1 from the x is exponent. 1 minus 1 is 0. The x goes away. We're going to subtract 2 from the y. 2 minus 2 is 0. Y goes away. So you just get 3. So you just have 3. Okay. 12 divided by 3 is 4. So plus 4. X to the second, take away 1 is x to the first, x. y to the third take away 2 is y to the first, y. This is our factored expression. The 3 would be the dimension that goes here. So this first rectangle has dimensions of 3xy squared by 3. If you multiply those, you get 9xy squared. This rectangle has dimensions of 4xy, the second part of this polynomial, and 3xy squared. If you multiply them, you get 12x squared y to the third. And this is the answer. These are the question marks. 3 is this question mark, 4xy is that question mark, and 3xy squared is that question mark. All right, so hopefully this works out okay. Again, this lesson's kind of tricky because it's your first factoring lesson. We'll do more in class, all right? Thanks for watching, and we'll see you in class.